Okay, now let us take few examples of factorization. Let us factorize 363. So how to factorize this number? Well, the method which is very easy to understand is, because we have learned the divisibility rules, so this method you will find very easy. So make two lines like this and write down 363 here. Now first start from 2. Whether this number is divisible by 2, well, there is no 0 and no even number at the end. So the number is not divisible by 2. So now come to 3. So the divisibility rule was, if you add the number 3 plus 6 plus 3, so 3 plus 6 plus 3 is 12. And 12 is divisible by 3. So the number is divisible by 3. So we put 3 here and we divide this number by 3. So 1, 2 and 1. Now let's take about what is this 121. So remember, I told you about the perfect squares, the concept which we discussed earlier, the perfect squares. So number 121 is a perfect square, and this number is a perfect square of 11, because you must, as soon as you look at this number, you should realize that this is the perfect square of 11. So it means if I divide this by 11, I will get 11. And that this 11 is a prime number, so it cannot be divided further. So except by itself. So we divide 11 with 11, we get 1. So when you get 1 here, it means the number has been factorized successfully. And now you multiply all these numbers, and these are the lowest multiples, lowest factors of this number. So 363 can be written as 1 multiplied by 11 multiplied by 11 multiplied by 3, and you can rearrange that in ascending order. 1 multiplied by 3 multiplied by 11 multiplied by 11. So now we have used two concepts to factorize this number. One is the concept of perfect squares. You should know at least perfect squares of first 20 numbers. And the second concept we have used is the divisibility rules, which we use here, which we use the divisibility rules. We use that this number is divisible by 3. So by using these two rules, we were able to factorize this number and find its lowest factors. And now let's take another example, which is 540. So again, put these two lines. Two, because it's 0, so 0 is divisible by 2. So 2 to 4, 1 and 4 is 14, 2 7s are 14, and then 0. Now again it's 0, so it means it is again divisible by 2, 1, 3, then 1 and 0, 10, so 135. Now it's not divisible by 2 anymore, because now at the end it is 5. It is divisible by 5, but first look at 3. So 5, 3, 8 and 1, 9. So it is also divisible by 3. So although it is divisible by 5, but because it is divisible by 3, if we add 1 plus 3 plus 5, we get 9. And 9 is divisible by 3, so it is divisible by 3. So we will take the smallest number of 5 and 3. So we will first divide it by 3. And now 3 4s, 1, 12, 1, 5 and 45 now. Now again, add 5 and 4, 9. 9 is divisible by 3, so the number is divisible by 3. So we put 3 here, 1, 5. Again it is 6, so the number is divisible by 3. So we again divide it by 3 and we get 5. And now there is only one number which can divide this, which is 5, and we get 1. Now we multiply all these and we get the smallest factors of 540. So we can write 540 equals to 1 multiplied by, you can arrange, you can skip the first next step and you can arrange this. There are 2 2s and 3 3s, so I can write 1 multiplied by 2 multiplied by 2, then 3 times 3, and 5. So these are the smallest factors of this number. You can see that if you use the divisibility rule of 9, 5 plus 4 is 9, 5 plus 4 is 9, and because it is divisible by 9, it means 9 is also a factor of this number. But we are most interested in the smallest factors which we have obtained using this method. I want to give you a concept of prime factors. We have factorized 2 numbers. One was 363 and the factors were 3 multiplied by 11 multiplied by 11. Also you can put 1. The second number was 540 and there were 2 2s and 3 3s and a 5. These are the factors, the smallest factors. Now if you look at these 2 factors, you will notice that all these numbers are prime numbers in both of these. These are all prime numbers. Prime numbers are the numbers which can only be divided by itself. 1, 2, 3, 5 and 11, all these are prime numbers, and therefore these are the prime factors of these numbers. These are the prime factors of these numbers. And as I mentioned earlier, that these smallest possible factors are very important for us because these are the prime numbers. They cannot be further factorized. So here is the rule which you should always keep in mind when finding these prime factors, is that there is only one unique set of prime factors. So prime factors provide you the unique solution of factorization of any number.